This is Physics Lab 1 charge tape. The purpose of this lab was to determine the interactions between the clear tape pieces with other objects and with another clear tape. It was to determine the excess charge on one piece of charge tape and to simulate these charge interactions with a computational model through Python. The findings were that the charged clear tape has a net positive charge. The charge of the tape was 1.25, 3 times 10 to the negative 8 coulombs, and the tape is deficient of 7.83 times 10 to the 10th electrons. These were the physical principles involved, including the Coulomb's law, which was involved in the electric force, the R vector in the net force equation, which is R observed minus R source, and then the Coulomb constant was also in that equation as seen below. Then Newton's second law was also involved with the net force equaling change in momentum over change in time and the velocity update formula. And lastly, the gravitation force on the charged tape was also involved near Earth, so it's negative mg in the y-hat direction, and g is that constant of 9.8 meters per second squared. So the physical principles involved was tape is a point charge, air resistance was ignored as an external force, and both tapes are assumed to have the same charge. This was the procedure involved to create the U-tape and suspend it. So the interaction between the two tapes were that they repelled, so they clearly had the same charge, and the U-tape in the hand attracted, and then the U-tape and the pen attracted. So the pen is negatively charged due to its interaction with the clothing because it's absorbed electrons from the clothing. Therefore, we can conclude that the U-tape is positively charged. The interaction between the suspended U-tape and other U-tape repelled, and this was the calculated separation distance of 0.028 meters. This was the free body diagram of the interactions between the two tapes. So the system was the suspended U-tape, and the surroundings was the held U-tape and the earth. So the electric forces are clearly repelling, and you can see that there is a net force of 0 here because the forces cancel out, and the forces here are labeled. So this was the experimental data with calculating the number of atoms and the tape weight, and then here's the length, width, vertical distance between two tapes, surface area, and atom area. This was the experimental data and calculations continued, the force of gravity calculated, the charge of the U-tape right here, and the deficient electrons calculated, and the ratio of deficient electrons to atoms here. So this was the computational model based on those constants, and we put in the net forces of gravity and electric force and them equaling 0. These were the computational model continued of the deficient electrons and then the charge. So this was the results of the computational model of the gravitational force and electric force. So basically, we conclude that the positive charge of the tape means there's an electron deficiency. So the suspended U-tape floating meant that the net force was 0 due to the gravitational and electrical force. Possible sources of error were inaccurate measures of the tape length/width and separation distance, rounding calculation errors, and then the held U-tape was not parallel to the suspended U-tape, so it could have been on an angle, which caused inaccurate separation distance measurements. So what if the electrons had positive charge and protons had negative charge? So the direction of the electric fields would actually switch if the charges switched, and the positively charged U-tape would be negatively charged, and still the observations would be the same. Like, although the charges are switched, the like charges still repel, and then the opposite charges still attract. So the charged pen would have a positive charge, and it would still attract to the tape. Why is it important to handle the charged tapes as little as possible? Like, what happens if it touches other things and comes into contact with your hands? So electrons are easily transferred between other objects, so touching the charged U-tape would result in a transfer of electrons or a transfer of charge, and it would decrease a positively charged U-tape. So the U-tape would gain electrons from the hand, which would decrease the positive charge of the tape. Thank you.